Okay, so we're going to look at this figure here, and notice that it's not a polygon. So it's not a polygon, meaning that this edge here is curved. We have a curve here. So because of that, well, we're in a little bit of a jam here because there's no formulas for curved shapes that I presented so far in this course. However, we can do something with the measure of the angle here, 78 degrees. So hopefully you've gotten into a rhythm from last week about how to approach this course. So the way that I'm going to do this is I'm going to just ask you if you want, you can do this in a separate notebook, or you can maybe squeeze it in if you printed out the actual material. So I'll turn the video off just so that we have better connection. And can you still hear me there? Okay, thank you. So, thank you. So we're going to try to find this angle here, theta, this Greek letter phi. So this letter here is phi. It's the Greek letter. And the way we're going to do that is by changing how this figure looks. So we're going to actually turn it into a polygon by getting rid of this curve here and then extending the edges as so. So this is now a figure that is a polygon. In other words, it has straight edges or straight sides. How many sides is this figure? Good. Okay. And before I actually start to do some extra math here, -2. No, it's 4 sides, Denny. You got 1, 2, 3, 4. Oh, shoot. I got you. I understand now. Okay. So before we actually solve this, I'm going to actually just label this angle here. I'm going to give this angle here a name. I'm going to call it X. All right. So we know that inside the figure, the total internal angle in the figure, as mentioned in the chat, thank you, Denny, thank you, Shalon, it's n minus 2 times 180, which in this case is 4 minus 2 times 180, which is how much? Very good. So we know that it's 360. We also know that if we add up all the angles on the inside, so let's talk about these angles here. We know that we have the Greek letter there that we're trying to solve for, plus 28 plus 13. I don't have my calculator with me, so I'm relying on you to do the calculator work. This way we're both actively engaged in this conversation. So if we could actually just move that stuff over, then we'd be good. So if I could do 360 and then take away this stuff, then we'd have the answer. But what's the problem? What's the problem here? X. Thank you, Denny. So you know what? Hindsight is 2020. So I'm going to go back in my little story here and say first, or later if you want, let's find X. So looking over here, can anybody tell me what X would be? Who knows what X is equal to? Thank you, Ram. Can you tell the class how you got that number? How did you get that number? Perfect. So Ram used the formula 360 minus 78. Now, why did they use that number there, or that formula? Because this, remember, that's a revolution. That's 360. So that's 360 degrees. Whoops. Okay, very good. So that means that X over here, X is equal to, I'm just going to copy your answer, Ram, 282 degrees. And now we are in good position to solve this question, everybody, because now we know what x is. We can just put 282 there. All right. Oh, can someone give the class the answer? 37. And I'm going to check against the answer key. Hopefully there's an answer key on this page. Yep, we're good. So as you can see in the booklet, the answers are at the bottom of the page. If you're not sure what I'm talking about, I'll show this 1 second. The answers are right here. You see them upside down? So usually in these booklets, the answers are on this page or the following page, but they are within that confine of the question. So this question really is like two key parts. So we have our first part here, which is one rule. So we can highlight these a little bit, make it look a little bit pretty. And then here, whoops. And then here is the second part of the question. And that, my friends, is how you do this compound equation type question. So this question actually, you could argue, is like a linear systems question because you're solving for, well, you have to introduce a new variable. You don't have to introduce the variable, but it's effective to introduce a new variable x. And then you have two equations with two unknowns. So you have this big equation here, which is the total angle equation. And then you have the equation for 360. So it was really nice listening to you and reading your assignments. For those that have shown me the assignments already, you talk about what you like to do and what your hobbies are and what math you like. And it was interesting to see that some students had pointed out that they like actually linear systems. So I thought that was really cool because that's kind of what I did my research in graduate school. So anyway, that was one of the questions I'd like to cover with you today. The next question is a challenge question. So before I proceed, does anybody need a little bit more time with this? Does anybody need a little bit more time with this question? I will post these solutions on Blackboard. Yeah, no problem, Michelle. I'll give you another minute, okay? So as you noticed, that's good, Shalan. You know, it's obviously hard to kind of know which ones to pick. Thank you, Zifeng. It's hard to pick which questions for the students to do, but it really the ones that I pick for you guys, I'm not trying to be like evil and pick the ones and then give you the hard ones later. I'm basing it on picking easy, medium, and hard, and also my past experience with students, which ones they had the most interest in doing. So those are the reasons I pick these questions. It's basically a feedback from past generations of students that have asked me questions. So hopefully, hopefully this is sufficient, and we can move on. And you don't have to do it the way that I did. No problem. You don't, and even the best part is there's so many ways to solve these questions. Awesome. Thank you, Michelle. So, Mike, not Michelle, right? Did I get that right? Sorry. Or am I wrong? Never mind. No, because I'm trying to. I was like, and because I have to tell you everybody here. I have about 160 students, and I think 4 students, their name and how they want their name to be said preferred. You know, like let's say it's Robert, and they want to be called Bob, or I'm just saying as an example. So I'm trying to keep in my head, like reinforcement. So if I say something like, let's say your name is whatever. Okay. Anyway. I'm going to move on before I put my foot in my mouth. Okay, so this question here is not on the test, and the solution is actually in the Chapter 2 booklet. So for that reason, I'm going to ask you to try this one on your own. For the stronger students that want a bit of a challenge. Yeah, I don't understand what that meant, so I was like, just moving on. For the students that want a bit of an extra challenge, please try this question. And eventually I will I'll put my answer I'll share my answer with you in class. Like I'll take a picture with my phone because it's one of my notebooks, right? I'll take a picture with my phone and I'll share a picture on the screen of how I did it. But I don't have that prepared for today because I first want you to try it on your own before I do that. So yeah, this question's pretty cool. I think that a lot of you will have fun doing it. And the answer that the professor for the person that wrote these booklets gives in the second booklet is different than the way that I did it. So at least you have two people's responses, so you get a bit of a variety of how to solve it. So let's go on here also to page 19. And I mentioned today's class is going to be very laid back. Like I did one question with you so far, and I'm just talking about some stuff now. This one here is extra reading. This is a special triangles. So as you might recognize in construction, or just in general in geometry, there are certain triangles that appear a lot and have very useful properties in terms of calculating angles and side relationships. So these two triangles, there's the 60-60-60 triangle or the equilateral triangle, which can be cut in half into this special triangle over here. And there's also another special triangle down here, which is this one. For this course, I'm not asking you to have these triangles memorized or anything, but for those that have studied in the Ontario curriculum, you, regardless of the mathematics course you took in high school, in grade 10, you would have seen these two triangles. You would have seen the 30-60 triangle and the 45 triangle. And you would have seen it for sure in Ontario in grade 10. I finished high school 20 years ago, and it was in high school when I was in grade 10. So unless someone's been in school longer than I have, like in terms of like high school a long time ago, whatever, then most likely you would have seen it. So that leaves us with two questions that I want to spend. Oh, absolutely, Danny. Yeah, yeah. That's definitely a no-brainer. If you've done drafting, then you've seen it for sure. So there's two questions at the end of the book. One involves this funny-looking cube here. So we're going to talk about this one second. I'm going to talk about this question first, though, which is the last page in the booklet. So the last page in chapter 1. Here's the question. Just take a moment to read it on your screen, and we will discuss shortly. Just take a moment and read the question. Okay, so the question here is that if I give you 3 sticks, here's a stick, and here's a stick. Can you take these 3 sticks, and they don't have to be the same length, they could be any length. Can these 3 sticks always form a triangle? Will they always form a triangle? Keyword always. No, no, and yes, and no, and no, and no. Yeah, it's a no. So the reason is that one of these sticks could be really, really long. Well, I was trying to draw it, but it's not reacting. There. There's no way you're going to make a triangle out of those sticks. See, this one here and this one here, they're not going to reach each other, so forget it. So the answer is definitely no. Then it says here, if your answer is no, then state a rule which is will tell you when it's possible or not. So there's a very famous rule here, which is that, so that's the rule, this thing right here. And you might be wondering, ABC, which is which? So if it was equal, Denny, if they were equal, it would be a straight line. So let's take Denny's argument there and build off of it, okay? So here's the first stick, and then there's the other 2 sticks, like that. See, if you have ABC, then if this is A plus B equals C, it doesn't work. And, or you're doing the C squared. Okay, so the thing is, what some people might be thinking about this thing, if you're thinking about this thing, so just a comment to that, A squared plus B squared equals C squared, or the Pythagorean theorem, it does not apply here. because it's not a right angle triangle. None of the, thank you. And this one is no good either. So we're brainstorming very well here. So this one's no good. Whoops. And this one's no good with the equal sign. It has to be greater than. It has to be greater than. And you might be wondering, that's it. Yes, Shalon. This is how you do it. This is the rule, okay? So this rule here is very famous. This rule is called the triangle inequality. And this will guarantee it's always true for any triangle. This is always true. It's always true for any triangle, no matter how you label the sides. Doesn't matter how you label the triangle. So let's take an example here that works. So here's a triangle. Let's say this is 10, and this is, I want to make the numbers different. This is 11, and this is 7. No, it doesn't matter which is the longer piece. It's true for any of the letters. Yeah, it doesn't matter which way you label it. It's true for all arrangements. If you want a more definitive way to write it, is to write that A plus C greater than B and B plus C greater than A. These are all true. They're all true. But if you want to be economical about it, you can use one of them as long as C is the longest side. So we only write one of them is fine, and that gets the deal done. So if you notice here, pick any side. I don't care which way you choose, okay, people? Any way you write it, it will work. So let's try this out. Let's take two of the sides and add them up. Ready? 11 plus 7 is greater than 10. Is that true or false? Is that true or false? Okay, how about this one? How about 11 plus 10? Is that greater than 7? True or false? And finally, 7 plus 10. Someone's car alarm is going off out there. Is that true? Oh my God, facts. Look at that. Yeah. So there you go. It works for any possibility. Now, I like to say it a different way. I like to say it a different way because it relates to everyday life, okay? So the way that I'll say it, I'll just say here John's interpretation. So don't say this is from a textbook. This is from your math teacher. I think a lot of you will like this. Oh, what do you think about that? Does that sentence make sense to you? So let me tell you a story. Here's my story. Thank you, Denny. Let's say that you want to start here. You want to go from here. Let's call that A. And you want to go here. And that's B. So you want, let's say that A is home and B is you want to go to the store. If you go to the direct way, it's 10. 10 kilometers, 10 whatever, right? Yeah, so AB is the direct P. Yeah, the indirect path is the scenic route. This is the direct path. I'll put a D with a circle on it. And I'll put a D with a circle on it here. And then the indirect path, let's give that a different color. I'm running out of colors here, people. Hang on. I'm having issues with my crayons. There's the indirect path. Yeah, can you imagine? Can you imagine I was that dense that I got crayons and I started writing on my screen? Anyway, let's not go there. Let's not go there. You can't see me right now, but I'm smiling, so don't worry. I'm not trying to be too much. Anyway, okay, I give up on that question. I hope that the explanation was worthy and you understood what I was trying to say there. So let's go back to this question here. And this is the last question we're going to do today. And then after that, if we finish a little bit early, I'll dismiss you and I'm gonna ask that you use the time that I give you to work on that first assignment, because that assignment is due today. So for those that showed up late today, there's a very easy assignment waiting for you on Blackboard called Assignment 1. And I need you to get it done by today, please, so that I can learn more about you. The assignment is basically introducing yourself to me, that's all, and telling me your favorite formula. Okay, so just read the question here and we'll discuss it shortly. Okay, so hopefully you got a little bit of an understanding of that. I'll tell you the question like as a little story with from my end. So imagine that you had this big block here, and each of this block is made of little cubes. So each of these little squares here, if you want in 3 dimensions, each of these things is a little cube. So that's a cube, that's a cube, that's a cube. Okay. Now each cube is 1 centimeter by 1 centimeter by 1 centimeter. So I'm not going to say centimeters. I'm just going to say 1 by 1 by 1. So in this case, the question, this cube here, this large cube here, is basically all of those little cubes put together. So how many little cubes are there in total? How many total cubes are there? 1,000. Can you let the class know how you got 1,000, Ram? That's correct. That's good. How did you get 1,000? Let's do it like a length, width, and a height. 10 by 10 by 10. Thank you, Shalon. 10 by 10 by 10. Yeah. So the total cubes is 10 by 10 by 10. Very good. Now imagine this cube here is just made of wood with no paint. Yeah. Denny, it's not 600. There's cubes on the inside. There's cubes on the inside. That's why. Okay. So if you think the answer is 600, there's actually 1,000 because it's filled. It's not just the outside. Okay, Denny. It's not just the outside border. Anybody else who said 600? We're not talking about the surface here. We're talking about the whole thing. I'm just talking about the total number of cubes. It's full. It's completely full of cubes. It's not like just the outside. It's a volume. Thank you. Okay, cool. So this cube here, some of you mentioned in your assignment that you like dealing with woodwork, which is pretty cool. So that is right up your alley. You can visualize this. These cubes have no paint on them. They're completely bare. They're just the natural color of wood. Then what you do is you take this big cube here, and they're glued together somewhat, and you dip it in paint. Now, when you dip it in paint, only the outside of this big structure gets painted, and on the inside, there's no paint. So what happens is after you paint it and you let it dry, you smash it. And this thing smashes into 1,000 little cubes. And some of those cubes are going to have paint on them. And some of those cubes are not going to have paint on them. And it's up to you to figure out and catalog how many cubes have paint on them and how many don't. But more specific, how many cubes have paint on 3, 2, or 1 of their faces. So as Denny mentioned, when we talk about faces, here's a cube, one of these baby cubes, like this one here. See this guy right here? That's this guy right here. So that cube has paint on how many faces? How many faces does it have paint on? By faces, I mean sides if you want. It's 3. Yeah, it's 3 because it's the top corner. So there's one here. I got to use all my colors today. Jeez, this is hilarious. And there's another one there. And bear with me, people, as I'm trying to unload highlighters like crazy here. And that one there. Okay, so there's 3. So what we're going to do. Yes, Denny?
Yeah, what I was saying was if you dip that in paint, only the exterior surface will have paint on them.
Yes.
It's different, like that's the first part of the question. How many little cubes will have paint? Then you can go on how many faces actually have paint on them, if they're 3, 2, or
I
1.
gotcha. I gotcha.
Yeah, that's
The
why I said 600, because there's 6 sides and 100 cubes on each face.
there's a small hiccup with that though, because when you count 100 over here and you count 100 over here, I got your logic. These guys you've double counted. You see this column here?
Okay, yeah. I see what you mean. Yeah, because that follows, it wraps around. Yeah,
Yes. So
gotcha.
it's a bit of a mess
Yeah,
cataloging it. So
yeah.
the good news is, thank you, Denny. That's a very good comment. I'm gonna get out my crayons and I'm gonna try to color things for you, not for you, but for the class. I mean, uh, what happened? There we go. So let's talk about how many of those little cubes have paint on 3 of their faces. So I'm gonna get out my highlighter and we're gonna find out where they are. So 3 of their faces. So we already mentioned that one of them is this guy here, right? The corner. Can anybody else point out where there might be another one? Or how many do you think there are in total? 8 is correct. Very good, people. 8 is correct. And the way that we get that, it's all the corners. Very good. I'm going to type this. I'm not going to write it. Okay? That's a very good comment there. Now, what about 2 faces? Okay, so this is where it gets a little bit interesting. You are both correct, Shalon and Denny. It's the edges. Now, keep in mind though, we can't count this guy and we can't count that guy because we've already counted them. So tell me, this thing in red here, how tall is it? How tall is that shape? It's 8. Good. So I'm going to write down something here. It'll help everybody get it. So it's going to be like this. It's going to be edges. How many edges are there on this big cube? How many edges does this thing have? Amir, very good work. Yeah, there's 12 edges to that thing. There's 12 edges. So the reason there's 12 edges is because we can count them. I'll use my highlighter. So let's count 12. Ready? 4 on top. See that? 4 on top. 4 on the bottom, even though it's invisible to you. So that's 8 now. And then where do you get 12? You go to the sky. Ready? 1, 2, 3, 4. So there's 12 of them. And that is equal to 96. 96, okay? Now one face. So one face is going to be like, imagine like a window. One face is going to be like this. See this? This is getting close to what Denny was talking about. So I'm trying to draw a window here. And it's going to be very, very sad because it's apologies for me. It's my stylus. It just keeps on going. It's like Blackboard doesn't like me or something today. Anyway, can you tell me the area of that purple thing, that square? Yeah, it's 64. Very good. So I'll say here, one face. Six times 64. Anybody have that? Okay, what's the number? I got 384. I'm trying to do mental math here now. 384? Okay. So now we have the following. So let's summarize this. We have these answers. We have in red, okay? We have 8, 96, 384. And now we have to do the last one. So how do you do 0 faces? There's 2 ways. Method one. Method one is do 1,000 minus 8 minus 96 minus 384. This is the cheap way. Can someone confirm on their calculator they get 512? Thank you. And then the alternative way, why did I have a 6? Very good question. Malik, give me 1 second, okay? I'll answer your question once I highlight this number. Okay, so Malik's question, are you talking about this 6 here? Malik, are you there? Okay. If you know when you roll a die, how many sides are on the die? When you roll a die, how many sides are on a die? So that's why it's 6, Malik. So each of the sides here there's 6 of them, and each of those 6 sides is 64 of these little cubes. Is that okay? So we'll go back here. So we'll just clarify, okay? Are you okay with this being 64? Is this okay that it's 64? Okay, but you have to go all the way around because there's 6 sides to this overall shape, not just this one side. If you examine it, just like when you roll a die, there's 6 sides to it. You need to look at all 6 sides. Cool. Thanks for the assist. Thanks for the assist, people. Okay, now here's the thing. This last question, you're very welcome. And this last question, that was funny because Shalon was saying, "Oh, I prefer method one." And to be honest with you, because method one, okay, let me explain. It might be better to use method two to play it safe. The reason I say that is, what if one of your answers earlier was wrong? Let's say that instead of 96, you had the wrong number. Now you go do this, and you're going to use a wrong number to get another number that's wrong as well. So, in my opinion, it's better to do method two, play it safe, and then use all 4 of your answers and make sure all 4 of your answers add up to 1,000. So keep the 1,000 kind of as your your check, you know, the ace up your sleeve. Okay, so it's pretty cool that we did this, but I think it'll impress you even more if I were to show you how you can make a formula out of this. So who would like to see a formula for any side, any number of sides? Who wants to see a formula for any number of sides? Can you explain zero faces again? Sure. Okay, so the way that we do this, so just to go back to Jifeng's question, the way that I'm doing it is, where are you, Jifeng? Jifeng, I want you to imagine an orange, right? Imagine an orange. I know it's a sphere. I know it's a sphere, but imagine that you peel off the skin. You know when you peel off the skin of an orange and then you eat the inside? What I'm asking you to do here is to peel off the skin of this thing here. Peel the skin off of it, and what shape will it have? If you were to peel off the skin of it, it would have another cube on the inside, like that. But this cube would be smaller. How much would that cube be? Well, it would be, instead of 10, it would be 8, and 8, and it would be 8, because it's the stuff on the inside. So that's how I got 888. Okay, so I'm going to spend the last little bit here, and then for those that want to just go do the assignment, for those that want to go do the assignment, just go do the assignment. You can leave class. I'm recording this anyway, and what I'm showing you now is just kind of like having fun. It's not like it's not important to the lecture, but it's cool. So what if the original cube is 10 by 10 by n instead of 10 by 10? You're very welcome. So what if the original cube was n by n by n instead of 10 by 10 by 10? I'm not going to develop the formula like really rigorously here because we're under a tight leash for time. but I am going to show you how I would do it. So I'm going to do here, I'll make a little table. I'll make a little table here, perhaps, is the way to go. And I'll say here, number of faces paint, and then number of cubes. I think you will appreciate this. I've shown this in class before, and students have been very excited to see this. So we can have 3 faces, 2 faces, 1 face, or no face. So if it's 3 faces, the answer is always 8. Because it doesn't matter how big or small the cube is, it's always going to have 8 overall corners. But what I want you to see here is that in the remaining things here, you always have the following numbers. You're always going to have 12, 12 times something. Or I'm just doing something on my computer. Okay, and when you have 1 face, remember how I was going back and forth there with somebody that was asking about the 6? I forget who it was, sorry. 6 times something. It's always going to be 6 times something. And then the rest of it is going to be involving n. So this is going to be n minus 2 cubed. This is going to be a squared, n minus 2 squared. And this is going to be n minus 2. This will always be true. And I can just figure total after some, let me put that in quotes, fun math. You're going to get n cubed. So I'm leaving that to you to as an exercise to figure out how I got all these expressions. But I just want to mention that if you take this stuff here and you add it together using a lot of algebra, and there's many people here that are really good with their algebra, if you take all this and expand it and simplify it, you're going to get n to the 3. So anyway, that's all I have for you today. I will post this stuff on Blackboard as soon as we're done class, and that's about it. So please take some time and go do that assignment for me. It won't take you that long.